Hello everybody, Sorlian here and welcome back to another mathematics video. In this video we will be looking at the types of angles, and at the end of this video we should be able to do a few things. One, we should be able to correctly label angles. Two, we should be able to correctly identify the different types of angles. And three, we should be able to determine the value of angles using the properties of different types of angles. So first of all, let's look at naming an angle. So normally, an angle is represented by three letters, and the three letters each represent a point, and the point guides you to the angle, guides you through the angle. And the middle letter is usually where the angle is at, and the two end ones are the guide to completing the angle. So for this angle that I have here, which is this piece here, and if I wanted to label this angle, we start from here and we go towards here, and then we go to the end part of this angle. So we can say the name of this angle would be BOA, and O would be where the angle is at, or some people may even label it as AOB. Both of them mean the same thing, AOB or BOA. We know that we're talking about the angle O in the center. So that is how we label an angle. So now let's look at some basics that we should remember about angles. So first thing, the angle of a straight line is equal to, we know the answer to this is 180 degrees. The number of degrees in a circle is equal to, we know the answer to this is, if you said 360, you're absolutely correct. And we know supplementary angles have a total of something degrees. And if you said 180, you are absolutely correct. And complementary angles have a total of, if you said 90 degrees, you are once again absolutely correct. So let's examine the use of some of these points that we have here. So first of all, calculate the measure of angle X. So you see angle X kind of completes a circle. We have this part here of the angle, this part is measured 150. We have from here to here is measured 160. I want to know what is the remaining piece here. So we see angle X completes a circle. See, if it completes a circle, we know that the total sum of the degrees in a circle is 360. So to find this answer, we can say angle X is equal to 360 degrees, subtract, and we just add up these two angles that we have here, which would be 150 plus 160. So we can say angle X is equal to 360 minus 150 plus 160 would give us 310. So we can say angle X is equal to 360 minus 310 would give us 50 degrees. So you can say here is equal to 50 degrees. So if you add up 150 plus 160 plus 50, we will get a value of 360. That completes the number of degrees in a circle. Our juices are flowing. Let's look at some of the types of angles that we want to look at in this video. So first of all, angles formed by intersecting line. The first one that we want to look at is vertically opposite angles. And it says, when two straight lines intersect, the angles that are opposite to each other are equal and are called vertically opposite angles. So in this example, we have this straight line here being intersected with this straight line. So what this rule or this property is saying, when two straight lines intersect, the angles that are opposite to each other are equal. So for this here, we can say this angle is equal to the angle opposite, which is this angle. So we can say angle A is equal to angle C. And we can also say this angle here is equal to this angle. So we can say angle B is equal to angle D. So vertically opposite angles are equal. So of course, let's look at some questions to answer under vertically opposite angles. So the question says, the first one, in the diagram shown below, calculate the value of X and of Y. So let's go. Let's calculate the value of angle X. So we see angle X, we have, first of all, we have two straight lines intersecting each other. So we see we have vertically opposite angles being formed. So if this angle here is 145, we can say angle X is equal to, since angle X is vertically opposite to that, we can say angle X is equal to 145 degrees. And then the same thing for angle Y. Angle Y is vertically opposite this 35 degrees. So we can say angle Y is equal to 35 degrees because the two angles are vertically opposite each other. Now let's look at another example. This one says, calculate the measure of angles X, Y, and Z. First of all, let's calculate the value of angle X. So we see angle X, once again, we have two straight lines intersecting each other, so we should have some vertically opposite angles. So if this angle is 55, the angle vertically opposite to that, which is angle X, will also be 55 degrees. So if there's 55 degrees, that means we can also find angle Y. Because if you look at angle Y, a straight angle is formed here. So this piece is 55, that means the remaining piece must give us 180 degrees. So you can say angle Y is equal to 180 degrees subtract 55 degrees. So we can say angle Y is equal to 180 subtract 55 will give us 125 degrees. So angle Y is equal to 125 degrees. So you can put that in here. 125 degrees. And last but not least, we want to find for angle Z. So angle Z is vertically opposite angle Y. So we can say angle Z is equal to 125 degrees as well. And that is how we can use the knowledge of vertically opposite angles to find for missing angles in a diagram. Now let's move on to corresponding angles. So corresponding angle says when a transversal cuts a pair of parallel lines, and by transversal we mean a straight line that cuts through two lines at distinct points. So when a transversal cuts a parallel line, the corresponding angles are equal. So corresponding angles are in the same relative position at each intersection. So same relative position at each intersection. Let's go through this theorem in detail. So we have two parallel lines here. We have these two lines that are parallel. So what this is saying is that because these two lines are parallel and this transversal XY cuts these two parallel lines, here, this angle here is equal to the angle in the same relevant position, which would be this angle here. So these two angles are equal. Also, this angle here will also be equal to this angle here because they are corresponding angles. They are in the same relative position. And also, this angle here will be equal to this angle because they are in the same relative position. And of course, this one will also be equal to this one. So now let's look at alternate angles. So alternate angles are angles that occur on opposite sides of the transversal line and are the same size. So basically they are equal. Alternate angles are equal. And we can often spot interior alternate angles by drawing the Z shape. So from the time we have two parallel lines and a Z is formed, then those angles are alternate angles and they are equal. So in this one here, we see we have two parallel lines again, and we have the transversal. So from the time the Z is formed, those two are alternate angles. So here we look for the Z again, alternate angles. Also we can look for the Z again. It's a different kind of Z. Alternate angles again. So you just need to look for the Z and you will have alternate angles. But remember, the lines that form the Z, they must be parallel. So, and then the transversal cuts it. So these two lines must be parallel. If the lines are not parallel, for example, if you have something like this, and it cuts here, and you think a Z is here. No, this cannot work because the two lines are not parallel. So let's look at another one. Next one says co-interior angles. So as you can see, all of these different types of angles deal with parallel lines. So this one says, when a transversal cuts a pair of parallel lines again, co-interior angles are supplementary. And earlier we learned that supplementary angles add up to a total of 180 degrees. So we can spot these by drawing the C shape. For alternate angles, we looked at Z. For co-interior angles, we look at C. So from the time we have parallel lines and a transversal cuts, these two angles are co-interior angles and they are supplementary, meaning they add up to 180. So as we can see, alternate angles, corresponding angles, and co-interior angles all deal with parallel lines being cut by a transversal. So the lines must be parallel. Key thing to note. If you want to apply these properties, the lines must be parallel. Key. So co-interior angles, they are supplementary. So we have an example here. So this angle here and this angle here are co-interior. So when we add up those two, we will get 180 degrees. And the same thing for angle I and J. When we add up those two internal angles, we will get 180 degrees. So now let's put our knowledge to the test by answering these two questions. So find the size of the angles marked A, B, C, etc. in each of the diagrams below. So let's go through that. So let's look at A. So first thing we want to do, well, let's look at this diagram. So the first thing we want to do, we want to find what is the size of angle A. So the size of angle A would be, so first of all, we have parallel lines because that is the symbol shown there. And we have a transversal cutting. And then we have a C being formed here. So because the C is formed, we can say that A is a co-interior angle to 110. So we can say A is equal to 180 subtract 110 because co-interior angles are supplementary. So we see angle A is equal to 180 subtract 110 would give us 70 degrees. So we see angle A is equal to 70 degrees. So we can put in that 70 degrees. Next thing we want to do, we want to find for angle B. So for angle B, once again, we see it's a co-interior angle. We see a C is formed, but it's a back to front C. So we can say angle B is equal to 180 subtract 40 this time. So B would be equal to 140 degrees because it's a co-interior angle. One thing we can do to check, so we know here is 140. So let's add up all of the angles inside of this shape because we know it's a four-sided shape, mean we should get 360 degrees as the sum. Let's see if we'll get 360. So we'll have 110 plus 140 plus 40 plus 70. And we will get 360 degrees. So we are correct. Now let's look at another diagram. So the other diagram, we have some shapes. We have some lines. So we have a parallel line here. We have a transversal cut in here and here as well. And they give us just this angle here. So let's use that knowledge to find for all the angles here. So we have 60 degrees here and we have A. The first thing we want to do is find A. So you can say A is equal to, so as we can see, we have a parallel line and a transversal being cut. And as you can see, A is vertically opposite to 60. So we can say A is equal to 60 degrees. And our reason would be because it's vertically opposite to 60. So you can say A is equal to 60 degrees. And the same thing we can do for C. We can find for C, which would be, we have a parallel line, transversal cutting, and here is 70, here will also be 70. So we can say C is equal to 70 degrees. And the reason would be because C is vertically opposite to 70. Next, we want to find B and D. So we can find for D one time. So we can say D would be equal to, so we see a C being formed here. So because the C is formed, we can say 60 and D, they are supplementary angles. So we can say D is equal to 180 subtract 60. Hence angle D is equal to 120 degrees. You can say D is equal to 120 degrees. We have A being 60, C being 70. So next thing we want to do is find for B. So we have another C being formed here as well. So we can say angle B and 70, they are supplementary. That means we add up B and 70, we should get 180. So we can say 180 subtract 70. That would give us angle B, which would give us 110 degrees. So we say angle B is equal to 110. So of course we can check to see if all of this will add up to 180. Let's just check to make sure. So we have 120 plus 70 plus 110 plus 60. That would give us 360 degrees. So with that, this has brought me to the end of this video. So we looked at corresponding angles, we looked at alternate angles, and we looked at co-interior angles. And one thing that we saw in all of these examples is that it involves parallel lines. So the lines must be parallel. So of course I must leave you with some homework, so you can take a screenshot of this and you can try to find for the missing angles and also give reasons for your answer. Either it's co-interior, alternate, corresponding, whatever reason you have, give a reason for your answer. So with that, I trust that you have a good understanding of these properties of angles, and I'll see you in the next video.